Hi students, here's the full worked out answer key for the final exam study guide. Please make sure you click on the description below to skip ahead to certain parts of the final exam so that you can watch whatever parts you want depending on the problem. So as always, we read the instructions first. Show your work. Partial credit may be earned on the final exam if work is shown. Remember, the final exam is all free response. There is no multiple choice, but it is open notes and you can use any notes from your notebook as well as worksheets that you previously completed. So let's begin. Part 1, integer operations. Select the expression that x equals -7 minus -12. So there are multiple ways to do this problem. One way to do it is by whenever we have a subtraction problem, we can use add the opposite method to figure out how to write the problem. So -7, and we're adding the opposite of -12. And the opposite of -12 is +12. So this method is called add the opposite. So -7 plus +12 will just be the same thing as -7 plus 12. Therefore, the answer is C. Moving on to the next problem. Number 2. The number line shows 4 elevations in Death Valley National Park. Find the difference in feet between the elevation at Zabriskie Point and Furnace Creek. So looking for the keywords, we are talking about the difference. Whenever we see the word difference, we're talking about subtraction. So we want to find the difference between Zabriskie Point, 648, minus -178. Remember, using the add the opposite method, we can rewrite this problem as 648 plus the opposite of -178 is +178. Rewriting this problem, we have 648 plus 178, and that's going to give us a total of 826. So our answer is C. For problems 3 and 4, values for x, y, and z are graphed on the number line shown. So we can see that x is -2 on the number line, y is +2, and z is +4. Use the graph below to evaluate the expressions in the table. Select one column for each row in the table to indicate whether the expression is less than 0, equal to 0, or greater than 0. So for our first problem, we have x minus y. X is -2 minus y, which is +2. And then for number 4, our problem is going to be z, which is +4, minus x, which is -2. Using add the opposite method, we'll start with number 3 first. So -2, we're adding. The opposite of +2 will be -2. And then, so we have -2. We start at -2. We can draw 2 counters that are negative, and then we add another -2. So that's another -2 counters. Our answer is going to be -4. So if our answer is -4, the answer is less than 0. With +4 minus -2, remember, add the opposite. So +4, adding the opposite of -2, which will be +2. So 4 plus 2 will be our new problem. And 4 plus 2 is just simply +6. So that's greater than 0. For number 5, find the value of -8 times 45 times 1/8. So whenever we're trying to multiply integers and rational numbers, you just want to multiply them one at a time. So we're going to multiply -8 times 45 first. -8 times 45. We have a negative and we have a positive. These two integers have different signs, so our answer has to be negative. 8 times 45 is 360. So we have -360. Now we need to take -360 and multiply that by 1/8. Whenever we're multiplying with fractions, we want to make sure that both of them are written as a fraction. So we have -360 times 1 which will give us negative 360. And 1 times 8 equals 8. So when we're multiplying fractions, we're just multiplying left to right. And our sign is going to be negative because we have two different signs, a positive sign and a negative sign, which gives us a final solution of a negative answer. So 360 divided by 8. So 8 goes into 36 4 times. That's 32. And then we have a remainder 4. So 8 goes into 40 5 times. The answer is negative 45. Number 6, find the value of 3/4 plus 7/12 minus negative 4. Remember, using the add the opposite method, this minus sign will become a positive, and we're adding the opposite of negative 4, which would be positive 4. So to rewrite this problem, we have 3/4 plus 7/12 plus positive 4, which is just plus 4. And we can rewrite 4 as 4 over 1. We want to find a common denominator between 4, 12, and 1. So we're going to make a list of factors for 4, which are 4, 8, 12, 16. For 12, it will be 12, 24, 36. And then for 1, it will be 1, 2, 3, 4, so forth, all the way to 12. You can see that 12 is what they all share in common. That's our lowest common denominator. As a result, we're going to multiply each of our fractions to have a denominator of 12. So 3/4 we would times by 3 in the denominator as well as the numerator. And then for our last fraction, 4 over 1, we're going to multiply by 12 in the numerator denominator. So our new equivalent fractions will be 3 times 3 is 9. 3 times 4 is 12, so 9 over 12, plus 7 over 12, plus 48 over 12, because 4 times 12 is 48. Now that we have a common denominator, we can add all our fractions together. So 48 plus 7 plus 9. So 9 plus 7 is 16, and 16 plus 48 is 64. So we have 64 over 12. And if you want to simplify that, we're going to take 64, goes inside the division house, divided by 12. 12 goes into 64 5 times. That gives us 60. We have a remainder of 4. So we have 5. This is the same thing as 5 and 4/12. But 4/12 can be simplified by dividing the numerator and denominator by 4. So our final solution is going to be 5 and 4 divided by 4 is 1. 12 divided by 4 is 3. 5 and 1/3. Number 7, find the value of 2.1 plus negative 3 minus negative 0.9. So let's rewrite this problem. So we have 2.1 plus negative 3 minus negative 0.9. So remember, when we have a subtraction problem, we add the opposite. So adding the opposite of negative 0.9 will be positive 0.9. When the signs are the same, when they're next to each other and they're the same, the final sign will be positive. And when the signs next to each other are different, the final sign will be negative. So we have right here, these signs are different. So we're going to have 2.1 minus 3. The final sign will be a negative. And when the signs are the same, the final sign will be positive. So we add that with 0.9. So first we're going to do 2.1 minus 3. Now, if you think about whole numbers, integers, if we think of this 2.1 as a 2, we would have positive 2, and then we would have negative 3. The answer would be negative 1. So we know that when we do 2.1 minus 3, we're going to have a negative answer. So let's write this out as 3 minus 2.1. And we know our answer has to be negative. So 3.0 minus 2.1, we're going to borrow from the 3. And 10 minus 1 is 9. And 2 minus 2 is 0. So we have 0.9. 2.1 minus 3 is going to be negative 0.9. Because we have more negatives than positives. So now we need to take the negative 0.9 and add 0.9. Okay? So we have negative 0.9, positive 0.9. That's going to give us 0. Okay? It's like saying negative 1 plus 1. That's 0. So our answer is B in this case. For number 8, select all possible values equivalent to negative 11 over 9. Remember that when we have two signs that are same signs, our final result is going to be a positive. And if we have two signs that are different, our final result is going to be negative. So we're going to take a look at these two signs, okay? So we have a negative. For A, we have a negative and negative. That means the answer is going to be positive 11 over 9. That's not the same thing as the original problem of negative 11 over 9. So it can't be A. For the second one, negative 2 and 1/9. Okay, well, why don't we try to do negative 11 divided by 9? Negative 11 divided by 9 is going to give us negative 1 because 9 goes in 11 one whole time, and we have a remainder of 2/9. That's obviously not the same thing as negative 2 and 1/9, so it can't be B. For C, we'll notice that we have two negatives right here, so that means we're going to have negative, those two negatives, same signs, it becomes a positive. So we have negative, positive 11 over 9. Now we have two signs that are different from each other, negative, positive. So negative and positive, two different signs, become, the final sign will be a negative. So this will be negative 11 over 9, which is the same thing as our original problem, negative 11 over 9. So the answer is C. And then for the last one, negative 1 and 2/9, as we solved earlier, it is exactly the same thing as negative 11 and 2/9. So it's also D. So for problem 8, the answers are C and D. For number 9, find the decimal equivalent of 13 over 8. So when we're trying to change fractions into decimals, we just do long division, 13 divided by 8. Remember, whatever number you say first goes inside the division house first. So 13 divided by 8. 8 goes into 13 one whole time. So 1 times 8 is 8. 13 minus 8 is 5. Now we need to bring down a 0. Remember, when we're doing long division, it's divide, multiply, subtract, and then bring down. So we're going to bring down the 0 next and follow the same process of dividing. 8 goes into 50. We need to add a decimal also. 8 goes into 50 6 times. So 6 times 8 is 48. So we divide it, we multiply, now we subtract. 50 minus 48 is 2. Now we bring down another 0. And then we divide again. 20 divided by 8. 8 goes into 20, a total of 2 times. And then we multiply. 2 times 8 is 16. Then we subtract and we have 4. Now we bring down another 0 until we have no more remainders or it's a repeating decimal. Lastly, we have 8 goes into 40. 8 goes into 40 5 times. 5 times 8 is 40. Then we subtract and we get 0. There's nothing else to bring down. So our final answer is D. Okay, so for part 3A, proportional relationships, no calculators allowed. Isabella is planning a trip to Western Samoa. Before going, she conducted some research and learned that the exchange rate is 6 tala for $2. How many tala would she need to exchange for $6? Okay, so we circled the important information and then we underlined the question. So whenever we have a word problem involving proportional relationships, we can set up proportions to solve this problem. We can also use tables, graphs, and equations to solve this as well. But in this problem, I'm just going to use it by setting up proportions. So 6 tala for $2. Remember, whenever we're doing problems like this and setting up proportions, we want to make sure our units are corresponding to each other. They match with each other. So how many tala, we don't know how many tala, would she need to exchange for $6? Notice how the dollars are the denominator and tala is in the numerator. So we want to find out how many times, if we can find a scale factor, do that. If not, we can clear fractions by multiplying both sides. So we're going to see if we have a scale factor. 2 goes into 6 3 times. So 2 times 3 is equal to 6. We do the same thing for the tala. Whatever we do to one side, we do to the other side. So 6 times 3 will also, this time, equal 18. So the number of tala we will have will be 18. and that's proportional. 6 divided by 2 is going to give us 3, and 18 divided by 6 is going to give us 3 as well. They have the same ratio. So our answer is C, 18. For number 11, this table shows a proportional relationship between the number of cups of sugar and flour used for a recipe. Determine the number of cups of sugar used for 1 cup of flour. Okay? They give us a table right here where we know that there's 2 cups of sugar, 5 cups of flour, 6 cups of sugar, 15 cups of flour, and 8 cups of sugar, 20 cups of flour. So we can see here that there's a scale factor going on. It's totally scaled out. That is, 2 times 3 will give us 6, and 5 times 3 gives us 15. And then we can also do it where 2 times 4 gives us 8, and 5 times 4 will give us 20. So this is a proportional relationship, as the problem states. Now, the question's asking, determine the number of cups of sugar used for 1 cup of flour. We need to find 1 cup of flour. So we have 1 cup of flour right here. If we're at 5 and we want to get to 1, we're going to divide it by 5, because 5 divided by 5 will give us 1. And we do the same thing to the other side. 2 divided by 5. So 2 divided by 5. We want to figure what that is to solve for the number of cups of sugar we need. And 2 divided by 5, we're going to do some long division. 2 divided by 5, 5 goes into 2, 0 times. So we add a decimal and add another 0. 5 goes into 20 4 times. 4 times 5 is 20. So the answer is going to be 0.4. For number 12, which table does not represent a proportional relationship between x and y? Remember, for tables and graphs to be proportional, as well as ratios, they need to have the same scale factor repeatedly. So we're going to check each of these out. We can see that 3 times 2 is 6, 2 times 2 is 4, 1 times 2 is 2, and 0 times 2 is 0. So in all these cases, it is proportional. The scale factor is 2. So it can't be that answer because it's asking us does not represent a proportional relationship. So for B, now we're going to check out the second one. 2 times 2 is 4. 4 times 2 is not 16. 6 times 2 is not 36. Instead, what we're seeing here is 4 times 4 is 16, and 6 times 6 is 36. So this is not proportional. Okay? So we know it is this one right here is the answer. Now we're going to check the last one. And we can see that 3 times 5 is 15, 6 times 5 is 30, and 9 times 5 is 45. So this is proportional. And remember, the problem's asking us which one is not proportional. So it's not that answer. So our answer is B for number 12. For number 13, select the graph that represents a proportional relationship between x and y. Remember, there's 2 key factors to determine if a graph is proportional. 1, it must be a straight line. Must be a straight line. And then 2, it must go through the origin. Must go through origin. And the origin is 0, 0. So let's see A. Is A a straight line? No, it's not. It does go through the origin, but it's not a straight line. B. Is it a straight line? Yes, it is. Does it go through the origin? No, it doesn't. So it can't be B. For C, is it a straight line? Yes. Does it go through the origin? Yes, it does. So the answer is C in this case. On to number 14. This graph shows a proportional relationship between x and y. Find the constant proportionality k. Using the value for k, identify the equation in the form of y equals kx. Remember, k represents our constant of proportionality. Okay, in other words, our scale factor. And to find this constant proportionality, we just take y divided by x. So we'll take a look at a point that we see that's exactly on the grid line. And if you look carefully at it, this point is exactly on the grid line. For this point, we have our x as 4 and our y is 9. So if we want to find our k value, it's 9 divided by 4. Therefore, our equation is going to be y equals to kx, and k is 9 over 4x. So that matches D. Our answer is D. Number 15. This graph shows the relationship between the number of hours H a business operates and the total cost of electricity. Based on the graph, determine which statement is false. So we're looking for which statement is false, not true. A, the total cost of electricity is $8 when operating the business for 80 hours. So let's look on the x-axis. We don't have 80 hours, and we look at $8. Our y-axis is $8. $8 is down here somewhere, okay? I think it's the other way around, where it's for 8 hours, it's $80. So this is false. Which statement is false? This statement is false. It should be $80 for 8 hours instead. The total cost of electricity is $10 when operating the business for 1 hour. So 1 hour, we can see it's actually at 10. 2 hours is at 20. 3 hours is at 30. 4 hours is at 40. So this is actually true, okay? Every hour is worth $10. Point A represents the total cost of electricity when operating for the business for 6 hours. So 6 hours right here, point A, 6 hours, and this represents the total cost. Yes, it does. So that's a true statement. And the cost of electricity is proportional to the number of business hours. Remember, proportional means that it's a straight line and it goes through the origin. This problem does have a straight line and it does go through the origin, so it's not D. So our final answer is A, number 15. Lastly, part 3B, proportional relationships, calculators allowed. An electrician is hired to install outdoor lighting. The electrician claims that the relationship between the number of hours worked and the total work fee is proportional. Okay, so we know it's proportional. The fee for 5 hours of work is $225. Okay, so 5 hours of work is $225. So we say hours is our X and dollars is our Y. We have 5 hours for $225. So remember, to find our K value, we know it's equal to Y over X. So Y is 225 over X, which is 5. 5 goes into 225. That goes in 45 times. 45 times 5 is 225. So we're trying to see, every time we have the number of hours, we multiply that by 45. So these to get our amount of dollars. So let's try this out. 6 times 45. Do we get 270? 6 times 45 will give us 270. So that's true. For B, 6.5 times 45. Do we get 315? 6.5 times 45 gives us $292.50. So it's not B. For C, 7 hours times 45. Does that give us 330? 7 times 45 is 315. It is not C. For D, 7.5 times 45. Does that give us $337.50? 7.5 times 45 gives us $337.50. So it is D. And for E, 8 times 45, does that give us 360? 8 times 45 does indeed give us 360. Therefore, our answers for 16 are A, D, and E. For 17, Jessica buys a sweater at a department store. The sweater costs $50. So it costs $50. The store is having a 25% off sale on everything in the store. What is the amount of money in dollars Jessica saves from the sale? So when we're talking about off, that means we're getting a discount. That means the price goes down. Okay? So we're trying to figure out how much Jessica saves from the sale. So if the sweater costs $50 and was saving 25%, we can multiply this by 0.25. That's how you write 25% as a decimal. And that ends up being $12.50. That's the savings. The question asks, what is the amount of money in dollars Jessica saves? So keyword is saves. We're not trying to find the final price. We're trying to find how much savings from the sale. So our answer is $12.50. Last problem. Arnold bought a motorcycle. He paid 8.5% in sales tax. The tax added $425 to the price of the motorcycle. What was the original price of the motorcycle, not including the tax? Okay, so this one's interesting. We know that we take the original price and we multiply it by our tax added. So when we multiply by the tax added, our sales tax in this case, we'll figure out the tax added. So let's see. Let's pick a number. Let's try out 4,000. Let's try out each answer one by one. 4,000, and our tax is 8.5%. 8.5% written as a decimal is 0.085. So let's take 4,000 and multiply by 0.085. What do we get? We get $340 in tax added. Well, the tax added we're supposed to get is supposed to be $425. It is not $340, so it can't be that answer. Now we're going to try B, 4,575 multiplied by 0.85. So 4,575 times 0.085 is $388.88 in tax added. That's not, once again, $425. So we know it can't be B as well. Now we're going to try C. We have $5,000. And we multiply that by 0.085. 5,000 times 8.5% is going to give us $425. Does that match the tax added? Yes, it does. So it's C. Let's do one more just to make sure that we're correct. We have 5,425 and we multiply by 0.085 to see what our tax added is. And when you multiply these two quantities, we have a total of $461.13. So that's not the tax added. So our answer is going to be C. That is all. Good luck on the final exam.